This is the Observability for Troubleshooting and Optimization with OpenTelemetry session. Real quick, though, I want to start with just a quick hand summary for folks here. How many of you are familiar with OpenTelemetry? How many of you are using OpenTelemetry? All right. How many of you are using logs from OpenTelemetry? How many people are using metrics from OpenTelemetry? Awesome. How many people are using traces? Very cool. OK. Awesome.
That's great.
Yeah. Good to know. So we'll introduce ourselves quick. I'm Josh Suereth. I'm a technical lead at Google Cloud. I'm responsible for observability and data collection. I'm also on the OpenTelemetry technical committee. So I contribute to it day to day. That's kind of what I do.
And I'm Mike Kelly. I'm the CEO at ObserveIQ. And at ObserveIQ, we build, we're the creators of BindPlane. It's a telemetry pipeline, orchestrates OpenTelemetry agents. And we also contribute quite a bit to the OpenTelemetry project.
Yeah, awesome. So today we're going to be walking you through three things. Basically, kind of a what is OTel? So for half of you, that might be a little bit of a refresher. The second is kind of major wins of adopting OTel that we've seen. And then the third is kind of an approach to adoption for how you can kind of use it in your organization and get started.
So since I know it sounds like a lot of you already are familiar with OpenTelemetry, we'll keep some of this brief, but at a high level, OpenTelemetry is an observability framework, and it's designed to create and manage your telemetry data. And what that means is it is a set of libraries, SDKs, agents. It has the goal of providing a single solution for gathering, processing, and transmitting all of your telemetry data. And in the past, that's been a challenging thing to solve because you're stuck with an assortment of different proprietary open source solutions to do the same thing. It really was the industry coming together to solve this. And that's why it's been something that is significant and that we want to talk about. The other way. So there are three things we're going to talk about with OpenTelemetry. And this is a very large project, obviously, but the three kind of core pillars we're going to talk about are the protocol. So this is well-defined protocols, specifications. It's really the base that everything else is built on. And it's the standards that are needed for collecting and processing the data. The next is instrumentation. So talking about the SDKs, libraries that you use within your own code, auto instrumentation, and others. And then finally, the OTel collector. This is the collector or agent. It's vendor agnostic, and it's what does the bulk of that processing of data and can be used to stream and create your telemetry pipelines within your environments. And then one last thing before we go into the details, because I think it's really important to understand why, what problem is this solving, right? And we think of this in there are a few key areas, a few big challenges that you run into with telemetry collection. One is standardization and simplification. So that is something that OpenTelemetry provides, and it's something that without it can be extremely difficult. And I talked with a customer. He's working in observability at a very large financial institution, and I asked, like I usually do at the beginning, what are you using for observability in terms of platforms? What do you use for application monitoring? What are you using for security? And his answer was all of it, right? And I suspect that is, people in this room know that feeling. Ideally, we want to consolidate tools. We also recognize that the reality is that that's really challenging. And the problem is, I think right now, there's a lot of focus on the consolidation of tools. How do we solve it from that end? But if you have a dozen different solutions, frequently you have a dozen different ways to collect that data and process it and transmit it. And that is a very difficult problem. And that's one that OpenTelemetry solves. So standardizing, simplifying, that is core. And then the next, and this is another critical piece, is that it's vendor neutral, right? So a core goal of OpenTelemetry from the very start was to provide a vendor neutral open source solution to gathering data, and that's what it's done. And last, without industry support, this isn't a solution that you can really adopt and count on. And this has OpenTelemetry, it's a CNCF project, the second largest behind Kubernetes. and it has the support of the vast majority of the industry. More and more platforms, they either have exporters to support data from OpenTelemetry or actually have native support for OpenTelemetry protocols.
Yeah, another thing I want to call out here is, with OpenTelemetry, you can keep your answer of, I use all of the vendors if you want. That's totally fine. What this does is let you change that answer as you wish going forward.
I'm sure lots of people want to keep everything, right?
So we're going to talk about the protocol. What's really important about the protocol is that it's the foundation to everything. This is what gives you that flexibility, and this is what lets you change your decision of your observability technology over time, is that we have this lingua franca of how to communicate the data, how to get it from A to B. There's three key parts to this. One is, it's a unified standard. This is a standard that we built, and we looked at existing standards and kind of tried to blend them together. So for example, we spent a lot of time with the Prometheus ecosystem guaranteeing that OpenTelemetry metrics and Prometheus metrics are compatible. If you've seen recently, Prometheus adopted OTLP for push-based metrics. So now a Prometheus server can even ingest OTLP as well. That's because we've spent so much time making sure that this protocol will be the standard and has pulled in all of these organizations and ecosystems around observability. We delayed a good bit to make sure that that was the case, but today the protocol is stable. It's 1.0, and it has logs, it has metrics, it has traces. Coming soon, we hope it has profiling. The other thing about this is it's correlated. One of the very principled opinions of OpenTelemetry is you should be able to use whatever observability data you have and use it in a correlated way, as opposed to struggling to understand, I got this alert, now how do I find my logs, right? You should have a consistent set of labels that are available across all of them. You should have consistent ways of migrating from one signal to the next. And the last bit is that it's stateless. The way that this should scale, the way that you should use this protocol internally should match how you scale your own systems generally. Stateless is kind of a big deal, for servers. We understand how to use load balancers. That's a foundational core component of most systems. So let's make sure this protocol scales the same way you're used to scaling.
And that's a key component of it. We'll talk about it more towards the end when we talk about deployment models, but it allows you to do things that you really couldn't otherwise. So now I'll talk just for a second about the OpenTelemetry collector. This is a collector. Sometimes I'll use that interchangeably with an agent that's designed to receive, process, and export data. That's it, but there's a lot there, right? And it's for all of your metrics, your traces and logs, events. It's really designed to handle all telemetry data. It's also designed to be performant. It's designed with usability in mind. It's designed to be extensible, either by you and your organizations or third parties. And it removes the need to have proprietary agents, multiple agents that you're managing. It really should be capable of replacing a lot of the agents that you have in your environment. And I will say, when we talk about the performance, usability, and extensibility, if you go to OpenTelemetry.io, you'll see that that is right in the primary goals that the entire team has agreed to. There are several components to the OTel collector. I'm just going to talk about the big three, because these are the core pieces that allow you to ingest, to process, and to transmit. One is receivers. And a receiver is just a component in the collector that allows you to ingest data. It could be gathering logs. It could be scraping metrics from an application like an Apache server. It could be ingesting data from OTLP or from syslog or other standards. But the idea behind this is that you should be able to collect all the data that you need from common applications. There are over 90 official receivers right now. Those are in the OTel project, and there are others provided by third parties. You can build your own and include them in your own distribution of the collector as well. Once you have the data in, then you want to process it. And this is optional, but frequently this is where you see a lot of benefit from OpenTelemetry. And processors just transform the data, just like it sounds. But they include things like Adding metadata. So maybe you want to add additional labels or key information as it flows through your telemetry pipeline. It also allows you to do things like redacting data. So if you want to remove identifiable information right at the host, you can do that. Filtering, batching, these are all things that you can do with processors. And then finally, once you've done all that, you've ingested, you've processed, you need to send it somewhere, and that's what exporters are for. And again, just like it sounds, they're exporters for all the common observability platforms. You can send data to Google Cloud, Kafka, Cassandra. Really, I could name all the vendors, and they typically have an exporter available to send data from OpenTelemetry. And I'll note that there is a receiver for OTLP and an exporter for OTLP, the standard OpenTelemetry protocol, and that is critical for chaining these collectors together so you have a true pipeline and you can send the data in a standard format.
So next we're going to talk about instrumentation, right? So this is, collectors is how do I take data that exists and get it from A to B? Instrumentation is how do I make that data to begin with, right? Where do I get my latency metrics? Where do I get my network metrics? Where do those CPU disk memory metrics come in? And there's basically three sources that we think about within OpenTelemetry, right? The first is what we call external, right? External would be if I'm using, say, a Java application. How many people here use Java? Yeah? Awesome. Okay. If you're familiar with JMX, it was this management protocol, right, that was designed to actually directly update values. And we started to maybe misuse the protocol for observability, where we will call this and look at the values that were available in this management interface and turn them into metrics. OpenTelemetry provides this in that collector as a receiver. It's a way for you to get data and observable data that you have today, right? Prometheus exporters, if you're familiar with the Prometheus ecosystem, are what we would consider an external kind of instrumentation, right? You run them on the side of the thing you're observing. The next type is automated, right? And this is kind of, sometimes we call it auto magic, right? This is where I can actually take a process that was not originally instrumented and I somehow manipulate it to now it is generating the telemetry directly. In OpenTelemetry, we have a few instances of this. There is a Java agent that you can run that will automatically generate telemetry. There is one for .NET. For Python and JavaScript, we call them agents, but really what they are is before we run your Python, we do an import where we inject a whole bunch of instrumentation. And same with Node.js, we'll inject a bunch of stuff and generate signals there. They support a whole bunch of common frameworks, Flask for Python, my bad, and like Express.js for JavaScript, for example. Those are automatically supported. You'll get latency metrics, that sort of thing out of the box. So that involves very little lift on your part. And the last is what we call manual instrumentation. And this is where you need some developer to write code to generate a signal. What we want to reserve this for a little bit is that when you have to take that level of effort, it should be important to your business, right? Like, I'm going to track maybe how many checkouts I have, if I'm selling stuff, or I want to track something very specific, right? I will have to manually go create a metric and do that. We have APIs and SDKs for that. But ideally, you should have instrumentation from the frameworks and, of whatever open source you're using, if it's available. And manuals should be limited to things that are very specific to your company, if I have a specific framework or whatever. We provide all three of those, and that's kind of how to view that space. Okay, so next up we're going to be talking about major wins of using OpenTelemetry. We're going to give you, I think, 3 different demos of some different things that we've done, and kind of talk through like why this is awesome, or at least why we think it's awesome.
So the first piece, and I talked about this a little bit already, but I think the big win from adopting OpenTelemetry, especially if you're able to deploy this throughout your organization, is standardization. And with standardization comes the creation of a data plane, right? If you have proprietary instrumentation, other open source solutions all mixed together, you really don't have that data plane, and it becomes really challenging to do some of the things that we're going to show you. But when you've standardized, you have a single system to learn, one system to deploy, one system to maintain. That by itself is a pretty significant win. It reduces complexity significant, especially as you scale out. So in the largest environments are the ones that see the biggest benefit from this. It improves control of your data. So that's one of the big goals of OpenTelemetry, is to give you control of your data. And that is something that you gain with the data plane. And there's no vendor lock-in, right? One of the great benefits once you have this in place is the ability to add additional destinations really easily. So one of the challenges that people run into is if you want to add, maybe you just want to test out a new solution, a new security solution, a new application monitoring solution. For some organizations, that is a heavy lift. And I've talked to folks that said that's a 6-month rollout for us. We need to re-instrument everything. We need to redeploy all of this. If you have a true data plane, it's a matter of redirecting and rerouting that data. So you already have access to it. You own it. You know, we're just sending it to a different destination.
Another example of that would be, say, I have a cloud deployment and I have an on-prem deployment, right? And I have a local observability solution for on-prem, but I want a global view of everything. Well, now I can route both places, right? I can send what data I want globally, and I can keep what I want locally. So I can do both. So now we're going to talk a little bit about tracing and optimization from OpenTelemetry. So in this example, basically, we try to create an e-commerce site that does auctions, right? And we're designing this using microservices in GKE Autopilot, and we have a couple microservices running. We have some user behavior that we're looking at. Users are able to kind of view items. They're able to place bids on available items. They're able to create new auctions, and they're able to finalize an auction and delete things. So what you'll see as we walk through this demo is you'll see those kind of show up as use cases that we'll see in traces. But we were running into a problem as we ran through this. So, all right. All right, so what you see here is the Google Cloud Trace API. We're using that one. You know, obviously you can use everything with OpenTelemetry. But in here you'll see just a summary of traces overall, of like traces in the past. We're going to go into the Trace Explorer. What we see here is a set of examples, you know, where a user actually talked to us, and we're looking at the latency that occurred. That on the right here are kind of attributes associated with spans and things where that tell us specifics to do diagnostics. On the left here, we actually see the latency of individual services and calls. If we look, you can see there's like get slash, there's get slash actions, get slash check. Those are actually calls, HTTP calls to different microservices. And we can look at different ones of these and kind of compare things. What I'm looking at right now is I'm noticing that read JSON, which is an independent span I've had, for some reason is taking a long time. When we first were developing this application, we weren't tracking how long JSON reads were taking, and we had these big, long holes in our traces of like, what the heck's happening here? So we started instrumenting our code and adding new spans, and we saw that JSON was taking forever. So then what we did was we created an experiment where we tried different read JSON frameworks. And this is me actually searching for those experimental spans. So we created one experiment called read JSON 1, one experiment called read JSON 2, and we have a random Boolean generator. When a user comes in, they get one or the other. And we're actually looking at live traffic, sorry, it's a demo, of the read JSON 1 implementation versus read JSON 2, and kind of evaluating those two traces to see what's changed, to see if there's any other impact from using a different implementation of JSON. So here you can just see us doing some filtering and looking for particular spans and that sort of thing that was generated by OpenTelemetry. Yeah, right here you can see we're looking for a really fast span at the bottom of that graph, and at the top we're seeing a very high latency span. It turns out that, you know, generally we saw all of one span at the bottom, all of one span at the top. Now, you don't have to do this by hand. You can actually see it right here. Under frequent URIs, it shows, oh, look, read JSON on average, read JSON 1 is way slower than read JSON 2, right? So I can individually look at something and try to figure out why a particular request was slow, but I can also see an aggregate. And we learned that, holy moly, the framework we used, their JSON reading library, is ridiculously slow. So Now, with this new improvement, we ended up actually overall improving the application.
Yeah. How many times have we found out that a JSON library is the culprit?
Yeah. How many times has reading JSON been like the major performance bottleneck in the system? Yeah,
everyone's run into it.
Totally been there.
Yeah, so, and a lot of people think when they think of OpenTelemetry, because it's where it started, they think of traces. But wanted to do another quick demo that just gets into logs and metrics. And this is another sample application, storefront application. It's instrumented with OpenTelemetry, gathering logs and metrics. Also has an Nginx load balancer, Postgres database backend. And we're just going to take a look at what this looks like. So in this case, I'm using bindplane just to manage those collectors. So we'll see that at the beginning. And so what we have here is a collector configuration. And this just helps you visualize. What we're doing is we're gathering log files from our storefront API. We're also gathering host metrics and logs. And then we're gathering metrics from Nginx as well. And then all of that's going through some processors, and we're sending that to GCP or Google Cloud Operations. You can see the amount of data that's flowing through that. And then just, let me pause it. We have it in a few different instances. So in this case, a small cluster of those hosts that are running this. This could just as easily be on Kubernetes. And then within Google Cloud, you can see those instances that are running. Now, from Google Cloud Operations and within Google Cloud Monitoring, we're also taking a look at things like status codes, latency by host, latency by path. We're sending all of the log, metric, and trace data through. And what this allows us to do is, and this is a simplified example here, but we're going to create an alert. We create an alert, and we're just looking for a spike in 500s, right? So to keep it simple, 500 status codes. When we see a metric come in that says we've seen a certain number of these, we're going to alert on that. And so I'm going to skip ahead a little bit just so we see what that looks like. Okay, so now we have the alert. And what's really nice about this, we're keeping all the data together. We're sending it to Google Cloud Operations. We can go in and look at this alert that was generated from a metric. And Google Cloud Operations automatically links that to the logs that are being generated as well. So we see the alert, and now we want context to help us troubleshoot. And so from here, we can just click into View Logs. And what that's going to do is filter down to that specific node that was having the issue. And it lets you diagnose and see when those error logs started. We can go in and look at the log specifically. We see that there are 500s that are coming through. And then we also have some detailed information on what the problem was. And in this case, it was specifically this node was running into issues connecting to that backend database. Right, so it lets you link this information together, and that's one of the things we can do when we pull together all the signals. And with this, we can do traces, we can do metrics and logs all together.
And one of the benefits of using OpenTelemetry is out of the box, you get the same set of labels between the three. Mm-hmm. So by default, all the telemetry will have a consistent set of labels and then the additional labels relevant to that particular data stream. So if you want to kind of look and do this correlated journey, it's a lot easier to find and see things. Another fun part is your logs will have trace IDs in them if you're tracing. And so you can actually search for logs and traces together. So in the Log Explorer, you can actually put a trace ID in, and you'll get the list of all the logs across all the servers to do that root cause analysis that you want.
The last short demo we have here, I'll get back to this. There we go. So this is something that I love about OpenTelemetry is the ability to create pipelines. So I told you about receivers and processors and exporters. And the power that you have with this, you can create a pipeline within a single collector, create a pipeline within multiple. But the idea here is that what we want to do is enable the user to enrich your telemetry data to filter out data that you don't need, right? So a lot of times you're collecting something and maybe you just want to remove that before it's sent to a specific destination. It allows you to do things like redacting PII, and then of course routing it wherever it needs to go. And that's critical because once you have a data plane, like we're talking about, you don't want all the data going to every destination, and so we're going to route it wherever it needs to go. And so I'm showing an example here of, I'm managing a few hundred OpenTelemetry agents. I'm going to go into a specific one, or a few of these, and this is a configuration. It's gathering data from Microsoft IaaS, metrics and logs, gathering host metrics and logs, gathering Windows events, and it's sending it to two different destinations, Elasticsearch and Google Cloud Operations. This is a pretty common scenario. We can see how much data is flowing through, but what we want to do is to start to add some processors. And in this case, we're going to add some filtering. So maybe with Elastic, we only want to send those critical errors. So we have filters. A lot of these are for filtering down, reducing data. Some of this is for deleting attributes, for transforming, adding attributes. And even you can add a custom processor in here. But in this case, we're going to look at filtering by severity. So on the left side, you see a sample snapshot of the data that's flowing through. On the right side, you see a simulation of what it's going to look like once this is applied. So in this case, we've significantly reduced the amount of data, but we're going to put in a couple more as well. With Windows events, a lot of times, you don't want PII data leaving the host or maybe leaving a network. And so we're going to filter out IP addresses that are available that are visible in the raw data. So in this case, we can say we want to mask that out. We have a lot of filters that are predefined. We're going to apply that to logs specifically. And when we look at the output after the fact, we'll see that that's masked. And any email addresses, credit card numbers, those would also be masked. And one last filter, sometimes we don't need full detail, and we can say we're only going to sample data, right? Maybe it's a random sampling, and that's enough for what we're looking for. And so in this case, we're sampling it. We're dropping half of those logs randomly. And so we'll apply all of these and then see the results. And I'm showing this in bind plane. Everything that I'm showing here can be done directly within a OpenTelemetry collector configuration. In this case, what we're seeing is, in this case, we've filtered out PII data going through events. We've dropped about half of the data leaving IaaS in terms of logs. And then we've reduced significantly the data that we're sending to Elastic. And that's the control that you get with processors and something that we're not going to talk about, but connectors as well.
Right, so now we're going to talk about basically ways to adopt OpenTelemetry in your organization and kind of, from helping a lot of companies adopt it and from working through it, like lessons we've learned a little bit. So there's basically 3 steps, right? The first thing is just to identify what you have. If you have every observability product, it's important to kind of understand that and then match it to OpenTelemetry. OpenTelemetry tries to give you the ability to take what you have and pull it into the OpenTelemetry ecosystem. So the OpenTelemetry collector, those receivers, there's hundreds of them. There's ones for almost any protocol you can imagine, and there's a bunch provided directly from vendors for a lot of their protocols, right? And the idea is you should be able to get that data into OpenTelemetry and into that format and start leveraging this standard protocol without having to fundamentally change your workloads, right? So identify what you have, figure out how to pull it in, right? The second thing is crafting that telemetry plane. This is something that you can take your time doing. You don't have to do it all at once. You can do the pieces that are most important to you and move them. But starting to move your data into the standard protocol, giving yourself that ability to do this filtering and enrichment live, right? And building that plane so that you have the control that you need for your observability. And then the last thing is you start filling in gaps. You started with what you had, And now this is when you start to lift and shift or replace. I decide that the observability I have is fundamentally missing. Say I want distributed tracing, I don't have it. Well, now I need to go start adding that distributed tracing, through my system. If I'm missing, say, metrics specific to latency on a particular service, I figure out how to go add that as a new type of instrumentation. So that's where you start getting that auto instrumentation and that manual instrumentation, right? Filling in the gaps of observability that you feel like you don't have. But first, start with what you have. Don't just try to, from scratch, cut and run. That's not what this is designed around. This is designed to kind of take you where you are, migrate in.
Yeah. And that's a good segue into the next, which we'll talk about a couple things. One is deployment patterns, and then one is some suggestions or best practices on how you might migrate to OpenTelemetry. So this is one of the simplest deployment patterns, not the simplest, but what I would say is this is the first one that I would suggest anyone would consider in their environments. And what's happening here is we've instrumented an application with an SDK. So we're gathering traces or logs or metrics directly from within the application. We're then sending that from OTLP to a collector that's separate from that host in that application. And then the data is processed and sent to the observability backend. There's some pros to this, right? It's really simple to get started. It's a great place to start. There's a clear mapping between that application and the collector. The cons are it's not as scalable as some of the other options, and it's not super flexible. But one thing you still can do with this is you can fan out. So you can take this model and you can start to send it to multiple destinations. So that's sort of the step one or phase one of deployment. The next is to actually deploy a collector as an agent. So sometimes we'll talk about the collector that's deployed on a host or say in a cluster as an agent. It's operating locally, so it can ingest logs and metrics directly from that system. It then is going to do processing. You can do the processing and move that off to the actual host itself, or in the collector that we would call a gateway, which is happening before it sends the data along to the destination. This is, I think, a great pattern, especially as you start to scale out. It does require that you're deploying a new application, or you do have to deploy that collector to all of the hosts.
One thing to call out about this particular model of having the two collectors that's rather important for observability, right? That local collector is only responsible for getting data off the machine and making sure that your application can get data off of itself as quickly as possible. What's the most important moment of observability? When you're crashing. So having something local to let you get stuff off of the process as fast as you possibly can is critical, right? And so that's one of the benefits that you get by having that local collector, but it should be minimal, right? And then its job is just to do any sort of local filtering and dropping necessary for that machine and then get it out the door. But it's about an error failure zone, right? It's not about, it's more flexible necessarily. It's actually giving you better observability when it's done well.
The next in this comes back to the statelessness of OpenTelemetry, OTLP. We can easily scale this out. So when you have larger environments, if you're dealing with larger amounts of telemetry data, you have high processing needs. The OTel collectors can scale out easily with a load balancer. If your volume is low, this is additional complexity that you may not need. And then kind of the ideal end state, the way that I think of it, is once you have this, if you have a local collector, you have your gateway collectors, these start to string together and they can chain together as needed. So you can do processing on your OTel collector gateway. They can be a gateway if you have, say, secure environments and you really can only expose one collector as the endpoint that's going to send data out. These can all sort of chain together, and then you've really, at this point, you've truly created a telemetry pipeline, a data layer.
Yeah, so now that you've seen kind of if you were to adopt OpenTelemetry from scratch, now we're gonna walk into, okay, what if you're not? I mean, most of us aren't, right?
Yeah.
Most of us already have observability of something, at least logs.
Yeah.
Let's look at how we take this and adapt it now, right? With that, start with what you have.
Yeah, that's the key thing. That's where a lot of people get, a lot of folks get concerned and say, well, how do we migrate from what we have? Because we already have a large existing deployment. We have proprietary agents, instrumentation, and they are maybe tied one-to-one with the platforms that we're using. But we recommend that you do this in stages, right? And ideally, this isn't always possible, but if you have a new application, new deployments that you're starting with, this is a great place to get started with OpenTelemetry. You can deploy OpenTelemetry in the architecture, the deployment model that you were planning on, and then send the data to the same locations that you were already expecting it to go, right? So this is a great spot. If you don't have a greenfield application available, it's choosing what is easiest in your environment. And that can be, sometimes that's about the team that's easiest to work with, right? That they're the ones that want to try this the most. But starting with one piece, and then that moves into phase 2. And I think this is something that sometimes folks are surprised by, but in the vast majority of cases, you can take the instrumentation that you already have installed, whether it's SDKs, proprietary SDKs, or it could be a different agent, proprietary or open source. You can redirect that data, and there is very likely to be a receiver in OpenTelemetry that will allow you to then convert it to OTLP. So if you start to shift those different workloads, redirect them into your new OpenTelemetry pipeline, you're getting a lot of the benefits that you would see otherwise. You just don't have that same instrumentation at the application level. And then the last phase is really starting to decide, what do we need to replace? And like Josh mentioned, sometimes that's on a case-by-case basis where you say, I need to fill in the gaps here. I don't have the visibility that I was hoping for. It's worth it to switch to this agent. It's worth it to really consolidate everything and make sure that we are consistent across all of our environments. But I guess the key point here is I want to make it clear that you don't need to do everything at once. And really moving through this in a staged approach is what we recommend. And it gets you to that same place, but you can do it over time.